Okay, class 9 students, let us try to learn more about isotopes and isobars by solving some numerical problem also based on isotopes, and that will be quite interesting. Last day we were talking about isotopes as isotopes are those atoms or atoms, different atoms of same element, which having atomic number same but mass number different. And if we are talking about the example, then last day we were going through different examples, like hydrogen has 3 isotopes, and those we can name protium, deuterium, and also tritium. So 3 isotopes. Oxygen has also 2 isotopes, oxygen 16 and oxygen 18. So when we talk about chlorine, chlorine has 2 isotopes, chlorine 35 and chlorine 37. So whenever we are talking about the atomic mass of any certain element, actually that is average atomic mass or weighted average atomic mass of the element, because any element could exist in form of isotopes. So last day we have learned all this. Today we will solve some question based on this. Let us solve maybe the first question. And then we will try to learn some more questions. The element boron. Boron, actually, boron has got the atomic number 5, and it exists in nature as 2 isotopes. So let us solve that question. So when we are talking about any particular question, so the element boron occurs which is an element of periodic table, maybe atomic number 5 here. The element boron occurs in nature as 2 isotopes. As 2 isotopes. Okay, let me bring second pen, because this pen has been finished. So let us use another pen. Let us use blue pen. I have got some more pens in my bag. इसको निकाल लेते हैं. So when we are talking about these isotopes, isotope numericals come in the exams, and you have to solve those numericals in a very proper fashion. Okay, so I have pen in my pocket. So let us go through the question. The element boron. This is very interesting question. Has come in CBSE 2016. That means it is most probable question also for any examination. So let us prepare nicely, solve this question nicely. The element boron occurs in nature as 2 isotopes having atomic mass (10U) and 11U, U or AMU, whatever. 10U and 11U. What are the percentages? What are the percentage abundance of these isotopes in a sample of boron having average atomic mass of 10.8 U. Average atomic mass 10.8 U. But these two isotopes has mass 10U and 11U. So what we have to find? The percentage abundance, any composition. Maybe in the 100%, one isotope is 60%, another 40% or 30 or 70 like that. You have to find this percentage. So how to solve this type of question? Let us solve this question. Here we have to use a formula, average atomic mass of boron, that is given 10.8 U. This is given. Boron symbol B. So average atomic mass is given. Now let this isotope B10 having percentage X% composition. Let isotope B10 has presence X% in the sample. Then isotope B11 will have 100 minus X% presence. Now average atomic mass of boron would be given as X% into 10U. 10U we can say, or 10. That is whatever is given, average atomic mass, plus 100 minus X% into 11U. Into 11U. So total percentage is how much? 100 minus X and X, 100%. This is given. Average atomic mass is given 10.8. So it is 10x plus 100 Actually 100 minus x into how much? 11. Cross multiplication we can do. Breaking the bracket. So we are bringing this 1100 this side. Ten x minus 11x. So we are getting x equal to 20%. 20%. That means B10 isotope has presence 20% and B11 has 100 minus 20, 80%. So our answer percentage of B11 is 80%. Answer. So here we are using a formula of average atomic mass of any element is actually the percentage of that into AMU of that isotope. Atomic mass unit of that isotope. Then again percentage into the percentage into AMU divided by total percent. That could be 100%. Okay, let us solve some other question. The average atomic mass of copper is 63.5 U. It exists as two isotopes. It exists as two isotopes, which are copper 63 and 65. Copper 63, copper 65. Atomic number same. So copper has got two isotopes. One has mass 63, another 65. Calculate the percentage of each present in it. Similar fashion, percentage, similar process we will use to get the answer. So let the percentage of copper isotope is X. The percentage of copper 65 will be 100 minus X. Now average atomic mass of copper is given how much? It's given 63.5 U. But your formula says so average atomic mass of copper will be equal to 63, that is X percent. So 63 into X plus 65 is present 100 minus X percent divided by 100. And average atomic mass is given how much? 63.5 U. So it is minus 2x, 6500 we will be bringing this side. So how much we are getting? Minus 150. So this X is 75%, 75 coming. So copper 63 is 75%. So this type of question is very important and you should learn how to solve this type of questions. So isotopes numerical problem important. Isotopes are actually the different atoms of same element. It is not different element responsible. It is the same element. One question I am giving you as an assignment. Average atomic mass of a sample of element X is 16.2 U. What are the percentage of isotopes? X16 and X18 in the sample. Average atomic mass of a sample of element X is 16.2 U. What are the percentages of isotopes So this type of question, actually the same type of question is there. The average atomic mass of a sample of an element is 16.2 U. What are the percentages of isotopes X16 and X18? Now I think you have pointed out this X could be oxygen also. So oxygen has got two isotopes, oxygen 16 and oxygen 18. So we have to find the percentage of these two isotopes in nature. That is very important. So next day we will solve some more questions. Okay students, thank you.